Hello learners, I am Dr. Subodh Kesharwani, working with Indira Gandhi National Open University in School of Management Studies. The topic which I am going to talk today is part of our program called MCO3, Research Methodology and Statistical Analysis, and we are here in the verge of fourth block, which more focus on the trend analysis, and that too, talking more about the probability and probability distribution as a whole. So we have already, two thought-provoking sessions which was focused on the probability distributions, and the curtain raiser to probability distribution, and then the type of probability distribution 1, which was more talking about the discrete probability distribution. So again, this particular session is talking about types of probability distribution 2, which is known as continuous probability distribution. And if you go into the backdrop, you will find out that discrete probability distribution was focusing more on the binomial, Poisson and hypergeometric, whereas continuous probability distribution is more emphasized on normal, uniform and exponential. So as far as probability distribution is concerned, both these types are quite important. Somewhere when we get an opportunity to use the discrete probability distribution, and somewhere else we are going to talk more about the continuous probability distribution. So let's recapitulate in a more faster mode. As far as the discrete random variable is concerned, it can assume a finite countable number of values with a break between successive values of the variable, where x is equal to 0, x is equal to 1, x is equal to 2. Consider the number of televisions in a household. X is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3, x is equal to 4 and so forth. So it's possible for a discrete variable to have the value 2.45, and it is impossible for a household to have 2.45 television sets, which is an example. So this is why we call the discrete random variable. So now taking into consideration, we are more emphasizing on the types of probability distribution 2, that is continuous probability distribution. There are many different classifications of probability distributions. Some of them include the normal distribution, chi-square distribution, binomial distribution and Poisson distribution. The different probability distributions serve different purposes, different data generation process. So here in this particular session, we are more talking about the continuous probability distribution. Also, and we have to remember that there are different types of quantitative variables called discrete or continuous. And what is the difference between discrete and continuous? Discrete data can only take on particular values in a range. Continuous data can take on any value in a range. So discrete data usually arise from counting, while continuous data usually arise from measuring. So this is a big difference between the two. And how tall is the plant? If we take one example, I think how tall is the plant given a new fertilizer? This is called continuous because this is something you are going to measure. So discrete data usually arise from counting, while continuous data usually arise from measuring. This we have already talked about. And if we go more into the backdrop of continuous probability distribution, in a continuous probability distribution, the variable of interest may take on any values within a given range. Suppose we are planning to release water for hydropower generation. Depending on how much water we have in the reservoir, whether it is above or below the normal level, we decide on the amount and time of release. The variable indicating the difference between the actual reservoir level and the normal level can take positive or negative values, integer or otherwise. Moreover, this value is contingent upon the inflow to the reservoir, which in turn is uncertain. This type of random variable, which can take an infinite number of values, is called a continuous random variable, and the probability distribution of such variable is called a continuous probability distribution. So, characteristics of continuous probability. The probability that continuous random variable x will assume a value between two possible values, x is equal to a and x is equal to b of the variable is equal to the area under the density curve between the values of x is equal to a and x is equal to b. The total area or probability under the density curve is equal to 1. The probability that continuous random variable x will assume a value between any two possible values, where x is equal to a and x is equal to b of the variable is between 0 and 1. So what I mean to say that if we go more into the backdrop of distribution of probability distribution, I think the pictorial presentation of all these probability distribution is available on our screen, and it is going to be explained with the help of that. If we talk about the normal, the shape could be like this. If we talk about binomial, the shape will be like this. If we talk about uniform, the shape will be like this, where we find that all the curves is in the same structure, in the same lines. Either it could be horizontal in nature or vertical in nature, whereas we find out in binomial there is a there is a ups and down, but still you find out the difference is there. So normal curves is a simple curve where you start with the 0 point and then go upward and then come downward. So anyway, we are going to talk more about these types of distribution with the help of some good examples, because when we talk about types of distribution, number of trials, if we are going to talk about binomial, how many success in trials is fixed. If you talk about the Poisson, good for more events, that is large n, small p, unknown, it is random, variable and potentially infinite. So hypergeometric, if we talk about used for all population without replacement. So what we mean to say that as far as the types of distribution is concerned, probability is concerned, I think with or without replacement example are there are certain examples are there. So there are few key difference between the binomial, Poisson and hypergeometric distribution, which we have already covered in our discrete model. These distribution are used in data science where there are dichotomous variables like yes or no, pass fail, the one picture sums up the major difference. So if we go more into the depth of this continuous probability distribution, I think it is going to be bifurcated in terms of three, that is uniform probability distribution, normal probability distribution and exponential probability distribution. So we start with continuous distribution. A continuous distribution variable can assume any value in an interval on the real time line or in a collection of intervals. It is not possible to talk about the probability of the random variable assuming a particular value. Instead, we talk about the probability of the random variable assuming a value with a given interval. So the probability of the random variable assuming a value with some given interval from x1 to x2 is defined to be the area under the graph of the probability density function between x1 and x2. And if we see this figure with respect to that, I think the nature of the uniform figure could be like this. The normal figure would be in a bell shaped and exponential figure could be in a exponential manner. So we start with the first probability distribution of, as far as the type of continuous probability distribution is concerned, is the normal probability distribution. And normal probability distribution is a distribution that represents the value of a continuous variable. If a continuous variable is said to be approximately normal, then the normal distribution can be used to model the continuous variable, and there are certain examples of distribution that can be modeled or approximated by the normal distribution, including IQ scores of the individuals, adult weights, blood pressure of men and women, tire wear, the size of the red blood cells and the time required to get to work. The importance of normal distribution is that it serves as a good model in approximating many distributions of real world phenomena. So if a variable is approximately normal, we can use mathematics to make predictions about the population regarding that variable. So the normal probability distribution is the most important distribution for describing a continuous random variable. It is widely used in statistical inferences. It has been used in wide variety of applications including heights of people, rainfall amount, test score, scientific measurement. And Abraham de Moivre, a French mathematician, published the doctrine of chances in 1733, and he derived the normal distribution as a function which is quite useful. So if you talk about the formula of normal distribution, it is fx is equal to 1 sigma and square roots of 2 pi and e to the power x minus mu whole square divided by 2 sigma square. So mu is a mean, sigma is standard deviation, pi is 3.14159 and e is 2.71828. So there are certain characteristics of normal distribution. The distribution is symmetric, its skewness measure is 0, and the entire family of normal probability distribution defined by mean mu and its standard deviation sigma. So if you see this particular image, it will be look like this. So the highest point on the normal curve is at the mean, which is also the median and mode. So there are certain mode characteristics. The mean can be any numerical value, -0 or positive. And the standard deviation determines the width of the curve. Larger value results in wider, flatter curves. So you see sigma equals to 15, the bell-shaped curve looks like this, and if the sigma is 25, the bell-shaped curve looks like this. So probabilities for the normal random variable are given by areas under the curve. The total area under the curve is 1, 0.5 to the left of the mean and 0.5 to the right. So 68.26% of values of normal random variable are within plus and minus 1 standard deviation of its mean, and 95.4% of values of normal random variable are within plus to minus 2 standard deviation of its mean. So 99.72% of the values of a normal random variable are within plus 2 minus 3 standard deviation of its mean. So there are certain characteristics basis of empirical value. If you see, if we are going to plot, I think the figure would be looks like this. So a random variable having a normal distribution with a mean of 0 and a standard deviation of 1 is said to have a standard normal probability distribution, and the letter Z is used to designate the standard normal random variable. So if you see that if we plot, the sigma is coming 1, so probability distribution random variable looks like this. And if you talk about the formula is 1 divided by sigma. In square roots we have 2 pi and then e to the power minus 1 by 2 and square of x minus mu upon sigma square. So if we are going to calculate this, I think this could be the way normal distribution for different values of mu is there. So normal distribution for different values of sigma is, if mu is equal to 1, it's look like this. So sigma is equal to 0.1, the shape is this. Sigma is equal to 0.3, the shape is this. If sigma is equal to 0.2, the shape is this. So three normal distribution with different areas are mentioned by this. If 68% is this, we can have a figure like this. If 95.4, the figure is like this, and 99.7, the figure is like this. So three normal distribution with three different. So what makes normal distribution a probability distribution? This is a question which need to be answered. Normal distribution, also known as Gaussian distribution, is a probability distribution that is symmetric about the mean, showing that data near the mean are more frequent in occurrence than than data far from the mean. In graph form, normal distribution will appear as a bell curve. And now the second is known as the uniform probability distribution. In statistics, a type of probability distribution in which all outcomes are equal likely. A coin also has a uniform distribution because the probability of getting either heads or tails in a coin toss is the same. So a random variable x is said to have a continuous uniform distribution over an interval alpha beta if its probability density function is constant k over entire range of x. So probability density function fx is equal to k, where alpha is less than x less than beta if the value is coming 0 otherwise. So how do you find the probability of uniform distribution? The general formula for the probability density function for the uniform distribution is fx is equal to 1 divided by b minus a, for a is less than or equal to x and less than or equal to b. So a is the location parameter. The location parameter tells you where the center of the graph is, and b is the scale parameter. The scale parameter stretches the graph out on the horizontal axis. So if we go more into the depth of this uniform probability distribution, a random variable is uniformly distributed whenever the probability is proportional to the interval's length. The uniform probability density function is quoted by fx is equal to 1 upon b minus a, for a is less than or equal to x, less than or equal to b elsewhere, and a is the smallest value a variable can assume and b is the largest value the variable can assume. So the most likely variable to have a uniform probability distribution is option C, the random variable which records the number between 0 and 1 generated by a random number generator, because the number generated by the random number generator are equally likely, that is the same probability for each number produced. So uniform probability distribution, if we talk in terms of expected value of x, where Ex is denoted by the expected value of x and equals to a plus b divided by 2. Variance of x is quoted by variance VARx and is equal to b minus a whole square divided by 12. So exponential probability distribution, if we more talk about, the exponential probability distribution is useful in describing the time it takes to complete a task. The exponential random variables can be used to describe time between vehicle arrival at a toll booth, time required to complete a questionnaire, distance between major defects in a highway. In waiting line application, the exponential distribution is often used for service times. A property of the exponential distribution is that the mean and standard deviation are equal. The exponential distribution is skewed to the right, its skewness measure is 2. So if we see the density function, I think the formula is fx equals to 1 by mu e to the power x upon mu for x is greater than or equal to 0, and mu is the expected or mean, and this exponential value is 2.71828. So cumulative probabilities, if you are going to talk about, where p is quoted by x less than or equal to x0 equals to 1 minus e minus x0 upon mu, and x0 equal to some specific value of x. So continuous variable model, if we are going to plot through this exponential distribution and taking x-axis time till the first fatal accident and probability is at the y-axis, and then we are going to plot the probability of the first fatal at time t equals to quoted by k e to the power minus tk, and the figure would be looks like this. So it's starting from left to right in a downward direction. So thank you very much.